criteria to terminate iteration procedure. See, iteration procedure means what? We have to repeat the process. We have to repeat the process or the method to improve the approximate route. Then, how many repetitions we have to do? We have to consider how many repetitions. Taking more number of iterations means it is very lengthy and time consuming. So, I have to stop this iterative procedure at some level. So, at what level I have to stop it? This is criteria to terminate the iterative process. Okay, there are two cases. Okay, the first one is the equation f of x equal to 0 is satisfied to a given accuracy or f of xk means approximate root, function value at xk is bounded by an error tolerance epsilon. Or another case is the magnitude of the difference between two successive iterates or approximations is smaller than a given accuracy or an error bound, one can say this is error bound epsilon. That is the difference between k plus 1th approximation and kth approximation is very very small, less than or equal to epsilon. And in this case, that is, one can write f of xk, the function value is very very small, less than epsilon. Okay, these two are the criteria to terminate the iteration procedure. Once again, let me explain the first point. What is our equation? We have to find the root of the equation f of x equal to 0, right? And I have to calculate what the initial approximate root, then first approximate root, second, and so on, kth approximate root, and so on. Then where I have to stop this process? That is, if, at some level, let us consider xk be the approximation, then function value is f of xk. That function f of xk must be bounded for the given error epsilon. This epsilon error is given in the will be given in the problem, maybe 10 power minus 2, 10 power minus 3, like that. Okay, then function value must be less than or equal to that epsilon value. Another case, these are the two successive approximations, x0 x1, next one x1 x2, next one xk plus 1. These two are the successive approximations, means pakka pakkana undadam okadani tarvata okati. Now two successive approximations, the difference between these two successive approximation is very very small, very epsilon always is very very small, like epsilon value is 10 power minus 2, 10 power minus 3, and so on, like this. Okay, now for example, if I require 2 decimal accuracy, then the iterate method stopped when the difference between the two successive roots xk plus 1 minus xk is less than 0.005. Here this 2 decimal accuracy means after decimal point there must be 2 zeros, remember. Similarly, if I require 3 decimal accuracy, if I require 3 decimal accuracy, then the difference between two successive approximate roots is less than 0.005 00005, 3 decimal accuracy. 3 decimal accuracy stands for after decimal place there must be 3 zeros. Okay, this is the criteria to stop the iterative procedure. Now let me start the first iterative procedure, the bisection method. The first method, bisection method. It is also called as Bolzano interval halving method. Interval halving method. Interval halving method. And what is the procedure? See, the bisection method process or procedure. Let me explain stepwise. The step 1 is first consider the equation. Consider the equation f of x equal to 0. The given equation, obviously it will be given in the problem. Step 2, locate the interval. Locate the interval closed a0 comma b0. How to locate the interval? By using intermediate mean value theorem. By intermediate I capital letter intermediate value theorem. Intermediate value theorem. Okay, locate the interval a0 comma b0 such that how to locate the interval? The product of f of a0 and f of b0 is less than 0. Means what? F of a0 and f of b0 are having opposite signs. Step 3, bisect the interval. Bisect means halving standing, nothing but bisect the interval. Bisect the interval, one can say this interval named with I0. Okay, bisect the interval I0, then I have a point M. I have a point M1, that is, it is the midpoint a plus b by 2. It is the midpoint a plus b by 2. Next step, here M1 equal to a0 plus b0 by 2 is the midpoint of a0 comma b0 interval. Okay, fifth step, if f of m1, substitute this m1 value in the function, f of m1 equal to 0, then m1 is the exact root. M1 is the exact root. Otherwise that means not equal to 0. F of m1 is maybe less than 0 or what? Either it is negative or positive. The next step 6. If, for example, I am telling if f of a0 is less than 0 and f of m1 is greater than 0, then the next approximate root, what is the next approximate root? Let me take m2. Next approximate root M2 belongs to what interval? a0 comma m1. Or the chance. What is the chance now? If f of a0 is greater than 0, okay, and this is now, let me take b. F of b0 is greater than 0 and f of m1 is less than 0, then the next approximate root the next approximate root, what is that? M2 belongs to what interval? Interval becomes what? M1 comma B0. M1 comma B0. To understand this concept, let me draw one line. See, this is the first interval A0 comma B0. And what is the first approximate root? This one, M1 is the first approximate root, midpoint, A0 plus B0 by 2. A0 plus B0 by 2. Next one, what I am calculating? F of M1. F of M1, it may be, if it is not equal to 0, then it is not exact root. So it may have negative sign or positive sign. Let us suppose that F of A0, this is negative. F of A0 is negative. Let me assume F of A0 less than 0 and F of B0 greater than 0. Okay. F of A0 less than 0, and if I calculate M1, at M1, F of M1, if it is positive, then what is this? Negative and a positive. Negative and a positive. Then the root lies between which interval? A0 comma M1. This one, A0 comma M1. And what is that root? M2. M2. And what is its value? It is again midpoint of this A0 comma M1 interval. This is the next approximate root. Okay. Next one, let us calculate. Therefore, seventh point. What is the seventh point? Seventh point, M2 will be what? Either A0 plus M1 by 2 or M2 will be what? M1 plus B0 by 2, whatever it is. Okay, or M1 either belongs to this interval A0 comma M1 or M1 comma B0 interval. But I am assuming the root is M2 belongs to A0 plus M2 equal to A0 plus M1 by 2. If I calculate M2, let me calculate M2. If M2 is, for example, F of M2 is positive, F of M2 is positive, then which is negative? F of A0 is negative, F of M2 positive. So next root lies between where? Here, that is M3, midpoint of the interval A0 comma M2, midpoint of the interval A0 comma M2. Okay, so in general, in bisection method, in general, repeating this procedure, we obtain the bisection method. We have the bisection method. Bisection method as mk plus 1 equal to some ak plus bk by 2, which can be written as ak plus 1 by 2 of the length of the interval bk minus ak, k equal to 0, 1, 2 and so on. Okay, actually this is the midpoint only. Okay, midpoint. That midpoint can be taken as in over the interval what? Ak comma bk. Bk minus ak means length of the interval. Ak plus half of this one. Okay. Anyway, midpoint of the interval. But what is the condition? What is the condition? Ak plus 1 comma bk plus 1. This is the interval. When this is possible. Now there is a change in bk plus 1 here. Observe this clearly. Ak comma, the root belongs to ak comma mk plus 1. If where, what is this? F of ak and f of mk plus 1, the product is negative. Or another chance is what? The root may be mk plus 1 comma bk plus 1. Mk plus 1 comma bk. If what is the condition? If f of mk plus 1 into f of bk is less than 0, using again intermediate value theorem. That means what? If f of ak, like previous slide I explained, f of ak into f of mk plus 1 less than 0, then root belongs to where? Ak and mk plus 1. If this one negative, the root belongs to what? Mk plus 1 bk. Is that clear? This is bisection method general formula. We take the lastly we take we take the midpoint of the last interval, as an approximate root, as an approximation to the root. This bisection method always convergent means definitely the successive approximations tends to exact root. Always convergent if, what is the condition here? F of x is continuous function. It must be continuous. F of x is continuous function in the interval closed a comma b, which contains the root. Means, what is the condition of convergence in bisection method? The function f of x must be continuous in over the interval ab, where the root belongs to this interval a comma b. Continuity means, the function must be defined at every point of the interval a comma b. Okay, and one more important point here. If this point is important, if an error tolerance means error value epsilon is given means prescribed, then the approximate number of the iterations required may be determined from the relation. What is the relation? B minus a by 2 to the power of n is less than or equal to epsilon. See, what is the condition here? This criteria, epsilon is the given error tolerance, and the question is how many number of iterations required. The question will be like this, just idea, how many number of iterations required to get 10 power minus 3 accuracy for so and so problem, for the root of some f of x equal to some function is given. This is one example roughly. Okay, to get that one, if n is the number of iterations, if n is the number of iterations, then the criteria will be b minus a by 2 power n less than or equal to epsilon. How this is possible? One can ask. This is a b. What is the length of this one? B minus a. Beginningly, what is the length of this one? Length of this one is b minus a. Okay, this is b minus a. Next one, what is the first root, approximate root? m1, midpoint of the interval m1. And for example, the next approximate root, then midpoint of the interval means what is this becomes? Length becomes b minus a by 2. This is the first iteration. Remember, first iteration b minus a by 2 power 1. For example, the next approximate root lies in this interval. This is m2. Then what is the next interval? This is b minus a by 2, and next interval is what? Up to here only. Let me write here. This total is b minus a by 2. Next interval is only up to here. And what is this? Is again bisect the length b minus a by 2, b minus a by 2 square. Second iteration b minus a by 2 power 2, and so on like this. So at nth iteration, what is the length of the interval becomes? Last interval length becomes, after n iterations, b minus a by 2 power n, and it must be less than or equal to epsilon. From this, what I am getting, taking logarithm on both sides, log of b minus a minus log 2 power n less than or equal to log epsilon. Then log b minus a minus log epsilon less than or equal to n log 2, correct? So what is n becomes n greater than or equal to log b minus a minus log epsilon whole by log 2. This is the value. This is the number of iterations n to get epsilon accuracy. Okay, this is the bisection method. Remember this. Now let us see one problem. Determine the interval where the root lies for the equation x cube minus x minus 4 equal to 0, and determine the root correct to 2 decimal accuracy. Solution. First, what is the function? F of x is x cube minus x minus 4. So how to locate the interval? Take trial values for x. 0, this is negative. F of 1, if I take 1 minus 4, this is minus 4 negative. And f of 2, if I take, this is 8 minus 2 minus 4, this is 2 positive. So what is this? Since f of 1 less than 0 and f of 2 greater than 0, that means f of 1 into f of 2 less than 0, the root belongs to which interval? The root xi belongs to the interval 1 comma 2. This is the location of the interval. Now the first iteration. In the first iteration, bisect the interval 1 comma 2. Then the first approximate root or initial approximate root is m1 equal to 1 plus 2 by 2, that is 1.5. This is the first approximate root. Then what I have to calculate? F of m1, that means f of 1.5. F of 1.5 is 1.5 cube minus 1.5 minus 4. It is less than 0. The value is less than 0. You calculate this value by using calculator. Definitely you will get less than 0. Then less than 0. So go for the second iteration. After calculating the f of m1 value, go for the second iteration. Now, which is a negative? F of m1 means what? F of 1.5 is less than 0, and which is positive in the previous interval? F of 2 is positive, right? F of 2, and f of 2 is greater than 0. The next approximate root, what is that? M2 belongs to what interval? 1.5 comma 2. 1.5 comma 2, and what it is? And is bisect this interval, that is 1.5 plus 2 by 2, that is 3.5 by 2, 1.75. Next, calculate f of m2. What is f of m2? 1.75 cube minus 1.75 minus 4. Okay, and you will get this value as negative. Now go to third iteration. What is the third iteration now? Since which is now positive, f of m2 f of m2 means what? F of 1.75 is less than 0 and which is positive? F of 2 is greater than 0. The next root, what is that? M3 belongs to what interval? 1.75 comma 2. 1.75 comma 2, and what it is? And is m3 is equal to 1.75 plus 2 by 2. 1.75 plus 2 by 2, this is 1.875. okay, now calculate f of m3, nothing but f of 1.875, this is 1.875 cube minus 1.875 minus 4. Now you will get this as positive, this as positive. Okay, then fourth iteration, what here you will get, since which is f of 1.875 is greater than 0, and in the third iteration which is negative, f of 1.5 is negative, and f of 1.75 is negative, the next approximate root, actually I have to write like this, the next approximate root, what is that? M4 belongs to what interval? 1.75 comma 1.875, and what it is? And is M4 is equals to 1.75 plus 1.875 by 2. okay, this is 1.8125. 1.8125. Now calculate this value, f of m4 value, that is f of 1.8125, that is 1.8125 cube minus 1.8125 minus 4. This value is positive. So fifth iteration, I will write like this, fifth iteration, since f of 1.8125 is positive, and in the fourth iteration which is negative, 1.75 is negative, the next approximate root, what is that? M5 belongs to what interval? 1.75 comma 1.8125, and is m5 is equals to what is the value? It's the midpoint, 1.75 plus 1.8125 by 2, and its value is 1.7125. Now if I proceed in this manner, proceed the iterations up to 10 iterations, then okay, then at ninth iteration, the root is m9 is equals to 1.794922. At a 10th iteration, the approximate root is m10 equal to 1.795898. okay, now mod m10 minus m9, the error between two successive, this is what? Error between two successive roots. What is this? Becomes 1.795898 minus 1.794922. what is this value? 6, 7, this is 9, this is 0, and this is 0, this is 0, and this is 0. Is that clear? Right? Okay. So 2 decimal, actually we are getting 3 decimal accuracy, right? This is enough. Therefore approximate root is after 10 iterations. Therefore approximate root is, this is what, is it correct? 1.795898, exactly right. This is 1.7422. what is the difference? 6, 7, this is 0, right? Okay, this is, therefore after 10 iterations, the approximate root correct to, actually we are getting 3 decimal, but required is 2 decimal is enough. 2 decimal places is x equal to, what is that? 1.795898. this is the answer. Now see, let me use the formula. What is the, for number of iterations, what is the formula? Number of iterations, n, to get epsilon accuracy. To get epsilon accuracy is what? b minus a by 2 power n is less than or equal to epsilon. And what is epsilon is given? 2 decimal accuracy means 10 power minus 2, right? So here epsilon is 10 power minus 2, 0.02 decimal accuracy means 10 power minus 3, 001, 2 decimal accuracy. Next what is n is as usual n, a value 1 starting interval, and b value 2. So what is this becomes? 2 minus 1 by 2 power n less than or equal to 10 power minus 3. 10 power, this is 3, 10 power minus 3. So what is this? 1 by 2 power n. 1 by 2 power n is 10 power minus 3. This is 2 power n is greater than or equal to 10 power 2 power n greater than or equal to 10 cube you will get. 10 cube you will get, right? 1 by 10 cube, yes, 2 power n is greater than 10 cube. Then how to calculate n value? Taking logarithm on both sides. N log 2 greater than or equal to 3 log 10. 3 log 10. So n is greater than or equal to 3 log 10 by log 2. This implies n is greater than or equal to 3 into log 10 value 1 point something, log 10 value 1 point something, and log 2 value 0.3010, I think, right? So what is this becomes? This is n greater than or equal to 9 point something something. So since n is an integer, we take n equal to 10.